So, good morning, everyone. So, in this session, we are going to discuss some of the questions that has been asked in NET-JRF Physical Science July 2025 paper related with electromagnetic theory. So, this will be the part 1, and in part 2, I will discuss the other questions. So, let's start. See, question number, we have this particular question. So, in this question, what is given? An electromagnetic wave EI cos kz plus omega t is incident normally on a perfectly reflecting mirror in a vacuum. If the permittivity is epsilon naught, you have to find the force exerted on area A. So it's a perfectly reflecting mirror. So you know that when you have a perfectly reflecting surface, if this incident intensity is I by C, so this will be the incident pressure, and then in this direction you will get minus I by C. So total pressure P is given by pressure exerted on the surface P is twice I by C. This result you know. If it is a perfectly absorbing, then it will be I by C. Because in this case, change of the momentum will be twice. So that's why you are getting twice I by C. And what is I? I is the intensity of the wave. So this is given by twice by C. And what is the intensity? You know that this is half C epsilon naught. If amplitude is, let's say amplitude is E0 square. And what will be the direction? In this case, wave is propagating in a negative Z direction. Just see, wave is propagating in a negative Z direction. So I will write, if you have to relate the direction also, because we have to write the force. So when we will write the force, we will take direction to be in the minus Z cap direction, because this is kz z plus omega t, that is propagating in minus Z direction. So first you should calculate the magnitude, and then we will see the direction also, because this pressure is force per unit area. So what will be force here? Force is given by, this is area into, this will cancel out, C will cancel out, this is epsilon naught, and here E naught is what? EI, mod of EI. So magnitude is mod of EI whole square, and I'm taking direction to be minus Z cap. So that will be the force. So you should write it as a minus A epsilon naught mod EI whole square. This is the amplitude of the incident wave, and this will be Z cap. Clear? So in this case, option D is correct. Is it clear? Option D is correct. So you have to remember the basic result. You must know what is the pressure exerted on a perfectly absorbing surface. When you have a perfectly reflecting surface, sometimes there is a oblique incidence also. So there will be a cos theta factor in that case. So these are the basic result that you should remember, so that you can solve the questions. Clear? So note it down. Now see next question. Now we will see next question. next question. Yes. So let us first see the statement. So in this a circular loop of radius a, this is a circular loop of radius a in the xy plane, and a square loop, this is in xy plane because this is x direction, this is y direction, and this is z direction. So circular loop is in xy plane, and a square loop of side b, that is in xz plane, this is in xz plane, are kept at a distance r. Both are carrying current I. So both are carrying current I. As shown in figure, this R is far, far greater than A and B both. So R is far, far greater than A and B both. Find the torque exerted on the square loop. You have to find what will be torque exerted on the square loop. So let's assume this is loop 1 and this is loop 2. So it's a small current loop. So what will be M1 for this loop? M1 is given as, that is magnetic dipole moment. So that is current into area of the loop. So this is I into pi a square, and its direction will be z cap according to right hand rule, because you know that if current is flowing uh, in the direction of phi cap, then dipole moment is in z cap. So using right hand rule, you can find the direction also. Magnitude is current into area of the loop. So that will be dipole moment for loop 1. And for loop 2, M2, because this is in xz plane, this is the direction of current. So according to right hand rule, direction will be y cap and magnitude will be I b square y cap. Okay? So that is the dipole moment. Now you have to find torque on loop 2. So this loop 2 is in external field of magnetic field of this loop. So what will be torque? So torque on dipole 2 is given by, this is M2 cross B1. You know that whenever a dipole is placed in an external field, it will experience a torque. So this torque we have to calculate. We know M2, now we have to find B1. B1 is the magnetic field due to circular loop at this point, at r distance away. So we know that what will be the magnetic field formula? Use this result. B is mu naught by 4 pi r cube. We will use coordinate free form. So this is 3 m dot r cap minus m. So if it is B1, so you should write here M1. And what is, because you are taking at r distance away, so what will be r cap? R cap is simply y cap. So B1 is given by, you should write B1 mu naught by 4 pi r cube. So this is 3 M1 z cap, because this is M1. M1 is this magnitude, direction is z cap, and this is dot y cap, and y cap minus M1 z cap. So I'm calculating the magnetic field due to this circular loop at this particular point. So because z dot y is 0, so this will give you B1 magnetic field is given by minus mu naught M1 by 4 pi r cube, direction is z cap. So you know M2, this value, you know B1, then you should find the torque. Now this will give you, torque is given by M2. M2 is, let's take it as M2 y cap. And B1 I am taking minus mu naught by 4 pi r cube M1 Z cap. And what is Y cap cross Z cap? That will give you X cap. So this will be given by minus mu naught by 4 pi R cube M1, M2 direction will be X cap. And what is M1 and M2? If you multiply magnitude M1 and M2 will give you what? Let's check. Mu naught by 4 pi R cube. This M1 is given by I pi A square. M2 is given by I B square. And this is X cap. And you have a minus sign here. So finally, torque is given by minus mu naught by 4 pi R cube. You will get pi I square A square B square X cap. Is it clear? So if you see which one is correct, so I think D minus mu naught by 4 pi R cube pi A square B square X cap. So option D is correct. So that is the case of a dipole in an external magnetic field. So magnetic field is in the case of dipole itself. So that's why I have calculated magnetic field due to this dipole, and then we have calculated the torque. So please note it down. Clear? So now let's see next question. Yes, this is the question. So it's a case of an optical fiber. So it's a 1 kilometer long. Length is given. Length L is here. L is 1 kilometer, or that is 1000 meter. Core refractive index. This is the core region. So I'm taking N1 to be 1.62, and this is cladding. This region is core, and this region is cladding. 1.52 is laid in a straight line. Several identical light pulses are launched simultaneously from an air. This region is air on the entrance of the fiber from different angle about its axis, as shown in below. The diameter of the fiber is small compared to its length. Length is very large. You have to see what is the maximum time difference between the pulses emerging at the other end of the fiber. So for maximum time difference, you have to see the maximum time difference. So we have to see which ray will take smallest, cover the smallest distance, and which one will take longest path. So the ray that will travel in this direction. So that will take the smallest path. So minimum time will be by this particular ray, and it will cover a distance L. So what will be, this will take a minimum time, T minimum. So minimum time taken is given by L by, let's say in core medium, this is V1. So this is given by L by C times of N1. So that is L N1 by C. L is 1000 meter, N1 is 1.62, and C is 3 into 10 to power 8. Clear? So now if you check the numerical value, I think this will be 5.4 microsecond. You have to check it. I have already calculated this value. So that is 5.4 microsecond. Now what will be the maximum time taken. So in this case, light ray that will propagate through the core region, it has maximum acceptance angle. Let's say this is the maximum acceptance angle. So what will happen at maximum acceptance angle? There will be, this angle is defined as theta A, where at core cladding interface, they will be just parallel to the interface. Means if incident angle exceeds theta A, means if incident angle is greater than theta A, there will be no total internal reflection. So for TIR, theta I should be less than theta A. So that's why I'm calling it as a theta A as a maximum acceptance angle. I'm calling it as a maximum acceptance angle. So let's say at this point, this is the critical angle that will satisfy at core cladding interface. Means at this angle, if incident angle exceeds theta C, there will be total internal reflection. If you are seeing at the core cladding interface. If you are seeing at AR core interface, if theta I is less than theta A, this is at AR core, then light will propagate through total internal reflection. So that's why this theta I should be slightly less than theta A, and for maximum time I am considering this particular angle. Let's say it is taking theta I is equal to theta A. So what will be now, if let's say this is propagating through total internal reflection after slightly greater than this value, and they are propagating through total internal reflection, and I am assuming this angle to be equal to 90 minus theta C, because this angle is 90 degree. Let's consider, because this angle is 90 degree. So take this angle to be 90 minus theta C. So what will be the maximum time if they are propagating through a total internal reflection? That is given by L by V1. Now you have to see component that is propagating in this direction. So that is velocity component will be cos 90 minus theta C. So because they are propagating at an angle, so I am taking this component. So that will give you lambda by V1 sine theta C. And V1 is C by N1. V1 is just like C by N1. So this you will get L by N1 C sine theta C. Now, what will be sine theta C at core cladding interface? What will happen? You will see sine theta C by, because this angle is 90 degree in cladding. So sine theta C by sine 90, that will give you, this is N2 by N1. So sine theta C is N2 by N1. So if you substitute this value, N2 by N1, so this will be L N1 square by Cn2. So that will be the maximum time. So you have to calculate again this value. This is 1000 into 1.62 whole square. This is 3 into 10 to the power 8 into 1.52. Let's calculate this value. So this is approximately, I have calculated this value. Let's take 5 this will be 5.7. Use calculator. This is microsecond. Now delta T maximum time difference, delta T max. So this will be T max minus T min. So this difference is minus 5.4. microsecond. And I think this will be 355.355. Let's point, this is 0.355 microsecond, or that will be 355 nanosecond. 355 nanosecond. So in this case, this option A is correct. Clear? So just solve it. Okay? So now let's see next question. Yes. See this question. So in this question, it's a long cylinder of radius r. Its radius is r. This is given, and it's a very long cylinder. And it's a magnetized cylinder. So magnetization M is K rho square phi cap, where rho is the variable distance. Instead of a small r, they have taken rho. Where K is a constant and rho is the radial distance. Rho is the radial distance. So it may be rho may for inside point, rho will be less than r. For outside point, rho will be greater than r. And from the axis, and phi cap is the azimuthal unit vector. Phi cap is this phi cap in cylindrical symmetry, azimuthal symmetry. You know the unit vector in the phi cap direction. Now you have to find the magnetic field inside and outside the cylinder. So just see, in these type of questions, when magnetization is given and when there is a no free current, and also there is a symmetry in the problem, so we can use a trick. In that case, you can directly take H is equal to 0, because when there is a no free current and also there is a symmetry, H field depends only on the free current. This point is very important. If you use that concept, you will directly get the answer. So what is that concept here? Since there is no free current, there is no free current, and also there is cylindrical symmetry. Cylindrical symmetry. So you have a symmetry of long wire. So H field is 0. You know that this H field depends on free current only when there is a symmetry. So this is valid for symmetrical case only. Whenever there is a symmetrical case and there is no free current, always take H is equal to 0. And you know that what is B? B is mu naught H plus M. And because H is 0, so B is simply mu naught M. This will be the magnetic field inside. So what you will do? For point when rho is less than r, means inside. Inside, B is given by simply this relation, mu naught. No need to calculate, just put here. So this is K rho square phi cap. This will be inside, and for outside point, because there is a no free current and outside the magnetized material, magnetic field is always 0, because bound current, field due to bound current outside the magnetized material is always 0. So B is equal to 0 for outside point. So inside you will get mu naught k rho square. Outside it is 0. So which one is correct? Mu naught k, I think, yes, B is correct. In this question, option B is correct. Inside mu naught m, outside it is 0. So if you use that concept, you can directly solve this question. Note it down. Okay? So let's see one more question. Yes. So first see the statement of the question that a thin circular wire loop of mass m. Its mass m is the mass of this loop, radius r, and this carries a static charge q. Total charge over it is q. The plane of the loop is perpendicular to the uniform magnetic field. B is perpendicular to this loop along the jet passing through its center as shown in figure. The loop is initially at rest, can freely rotate about z-axis. It can freely rotate about z-axis. So when the magnetic field is switched off, the loop starts rotating with angular frequency. By what frequency? So why it will rotate? So because when there is a changing magnetic field, there will be induced electric field. Because magnetic field is decreasing from B to 0. So there will be change in magnetic flux and that will produce induced electric field. And when there is an induced electric field, the charges that are inside, they will experience force, and you will see induced electric field is in the phi cap direction in this symmetry because magnetic field is along z direction. So these charges will rotate they will experience force. So this loop will rotate in the phi cap direction and there will be its angular frequency that we have to find. Okay? So how to find the induced electric field first? Let's see. We will take, since B is switched off, so there is changing, there is induced electric field. So there is a changing magnetic flux. There is a changing magnetic flux. So electric field will be induced. Field will be induced. So what will be the direction of induced? Because magnetic field is varying along z direction. So induced electric field will be always in the xy plane, in the phi cap direction, whether phi cap or minus phi cap, because of the symmetry, because that induced electric field will produce current and that current will be in the plus minus z cap direction. So that's why you have to identify what will be the direction of induced electric field. What is the direction of induced electric field? So induced electric field will be here in the phi cap direction. That we have identified. That induced electric field will be in the, it has only phi cap component. So how to find induced electric field? You know this result that closed E dot dl is given by minus d phi m by dt. Now you have to see at this point what will be induced electric field. So I am taking induced electric field is, let's say it has E phi component at R. So E dot dl, they are in the same direction. So dl will give you 2 pi r. And what is the magnetic flux here? So magnetic flux is given by through this is pi r square, and then you have a magnetic field B. B is a function of time here. So what you will get? This will give you minus pi r square dB by dt, because here magnetic field is changing. So this will give you what will be the induced electric field at this point. So this pi will cancel out, this r will cancel out. So this is minus r by 2 dB by dt. Okay? So there is an induced electric field. So what will happen? If you consider some elemental charge, let's say this elemental charge is dq. So what will be force experienced by elemental charge? So force on a elemental charge, that will be in the phi cap direction. Elemental charge dq is, let's say that force will be also in the phi cap direction. So this is dq into E phi, Q into E, because induced electric field is in the phi cap direction. This force will be also in that direction. Yes or no? And that you should calculate. This will be given by, what will be the total force? Now this will give you the total force. Or let us first calculate the torque experienced by it. So if this is a force, so there will be torque experienced by this elemental charge dq about the origin. So torque experienced, you have a torque about the z axis. Torque about the z axis. This will be given by d tau z, and this is r into d f phi. So if you multiply with r, this will give you, this is r dq E phi r d phi. So torque about the z axis is r dq E phi. And what will be the total torque? So then total torque is given by on all charges. So that will be given by simply rq E phi. This will be the total charge. Now you can take this tau z is also written as, this value is m, you should write torque is given by I d omega by dt. I into alpha. Omega is the angular frequency with which it is rotating. So this will be I d omega by dt. And what is I? Moment of inertia about that axis. So this is mr square d omega by dt. And that should be rq, q into r. And then you have minus r by 2 dB by dt. This will be the value. So what you will get? This will give you m times d omega by dt. And this r square will cancel out from this side. So that is, this is dB by dt. So you will get minus q by 2 dB by dt. Okay? Now see, from this equation, if you integrate both sides with respect to let's write this equation. D omega minus Q by T dB. So when initial amplitude is B, when it is constant, it will be 0. But when this becomes 0, this becomes omega. So you will get m into omega, and this will give you what? QB by 2. So I think this omega will be QB by 2m. So omega is QB by 2m. So in this case, option B is correct. Clear? So in today's session, I have taken these 4 questions. Tomorrow also we will take some more problem based on electromagnetic theory question related with the July 2025 question paper. Is it clear? ठीक है? चलो फिर. Okay. Thank you. Thank you everyone.